So here we go, I'm doing the first mechanics lesson on the AS Mechanics course, chapter 9.1, example 1. So as with any other question that we have to face, the first thing we need to do is read it through and pick out key information. So a cyclist rides in a straight line for 20 minutes. She waits for half an hour, then returns in a straight line to her starting point in 15 minutes. This is a displacement time graph of her journey. Work out the average velocity for each stage of the journey in kilometres per hour. Okay, so first thing we need to do is make sure we've understood what the word average velocity means. So the average velocity, well, velocity is what we call a vector quantity. And it has magnitude and direction. So as it's a straight line, the direction is fixed. A straight line. So the direction is fixed. We will have a positive and a negative direction. So we're going to assume that on the way out it's the positive and on the way back it's negative. How is that fact that it's positive and negative reflected on the graph? Well, the positive direction is shown by a positive gradient and the negative direction is shown by a negative gradient because it returns to where it started from. Okay, so average velocity, what else do we need to learn? So the average velocity is equal to, learn the total displacement over the time taken. So for part A, we have got average velocity, so average velocity is equal to the total displacement. Well, we can read that off the graph. 5, and the time taken is 20. Go back, that gives us, read the question, work out the average velocity of each stage, so we've got that, in kilometres per hour. So units, think carefully. So this was, the units here at the moment are in kilometres per minute. So 20 minutes, it's probably best to convert to hours. 20 minutes is equal to 1/3 of an hour. So we get 5 divided by 1/3, dividing by a fraction, invert and multiply, we get 15 kilometres per hour. Right, just a little aside, we should have learnt this in the pure part of the course, but just to remember, A over B over C is equal to AC over B. Dividing by a fraction, invert and multiply. Okay. part B. Let's go back, have a look. The average velocity for the whole journey. But the key, the prompt in the question is actually here, right down. Okay, the average velocity for the whole journey. Well, what can we see on the graph? The cyclist rides away for 20 minutes and then he cycles back for 15 minutes but returns to where he started because his displacement at the end from the graph is 0. Yeah, we can read that back along here and we get 0. So average velocity for the whole journey is equal to 0. Part C. Write out the average speed. Okay, so average speed we need to learn is equal to the total distance travelled over the total time taken. So we get average speed is equal to the total distance, which is 5 on the way out. Yeah, so again we're reading off from here. 5 on the way out and therefore 5 on the way back. So it's a total distance of 5 plus 5 over the total time is 65 minutes. 65 minutes, so that's kilometre per minute. But we want to convert it to hours. For 65 minutes is equal to 13 over 12 hours. 1 1/12 of an hour. So we've got 10 over 13 over 12. Using the method before, we get 120 over 13 kilometres per hour. You could tap that in a calculator and get it as a decimal. It's going to be 9.2-ish, I would think. Okay, and I've just realised I've missed out the rest of part A, because what did I do? Work out the average speed, average velocity, and I didn't even highlight it when I read the question, for each stage. So we've done the first stage at the moment, so I'm going to go back and do stage A to B and B to C. So that was average velocity that we've done here, which was O to A. So A continued, sorry about the order, A continued, we get A to B. It's a horizontal line, so they're not getting any further away. Yeah, in this section, yeah, no change in displacement. Therefore, velocity is equal to 0. So, average velocity, AB, average velocity is equal to 0. What was it in kilometres per hour? And then we've got BC, average velocity BC is equal to the displacement. Well, displacement has direction. Yeah, displacement is a vector quantity. It has direction. So we're going from so we were going from 5 kilometers away, yeah, back to the start. So from 5 kilometers away back to where we started. So the direction of that displacement is -5. So average velocity will be -5, and the time taken was 15 minutes, which is quarter of an hour. So we get -20 kilometers per hour.